Okay, let's unpack this.
Let's do it.
We're diving into how these massive AI models are learning to, well, watch and understand video.
Right.
And for a long time, the thinking has been that to solve the really hard problems, these models need what's called chain of thought reasoning.
That sort of step-by-step internal monologue.
Exactly.
Yeah.
But the sources we're looking at today show something, well, something really counterintuitive when you apply that to video.
They really do, because video is so much about just, pure visual perception.
And here's the finding. For a lot of these big video models, just giving a direct, quick answer, it often works just as well, or sometimes even better, than that whole expensive reasoning process.
It does. And that's where the efficiency problem just hits hard. If the model is always thinking, always generating hundreds of tokens of text for every simple thing it sees.
It's just creating lag. It's wasting compute power.
A huge waste.
So the mission becomes pretty clear. We need an AI that's smart about when it decides to think. And that brings us to this new framework, VideoAuto-R1.
Which is designed for exactly that, a kind of reason when necessary approach.
And the inefficiency of the old way, the always thinking way, is really clear in the numbers. We're talking about models that usually generate, around 149 tokens?
Yeah, on average, VideoAuto-R1 gets that down to just 44 tokens. It's a massive improvement. But the big question is, how do you actually train a model to know when to stop thinking?
And that's the really brilliant part. It's this new training idea they call thinking once, answering twice, or CoT.
Right. So how does it learn without a person telling it, this one's easy, this one's hard?
It sort of teaches itself.
Yep.
During the training phase, the model gives a quick initial answer first.
Okay.
Then, no matter what, it does the full reasoning step and produces a second reviewed answer.
And because both answers get scored for accuracy, the model just venture. It learns the value of that extra work. It figures out when that reasoning step actually helps.
So no manual labels needed. The real genius, though, seems to be at inference time, the early exit strategy.
Yeah. Yes. It's like the AI has its own confidence meter.
How does that work in practice?
So it sees a new video, gives that first fast answer, and then immediately checks some confidence level. If that confidence is super high, say 90% sure it's right, it just stops. That's it, answer delivered. But if the confidence is low...
That's the trigger. That uncertainty tells it, okay, time to do the deep dive.
Exactly. It kicks off the full chain of thought process and gives that more considered, reviewed answer.
And you can see this adaptive strategy playing out so clearly in the performance data.
Oh, absolutely.
On tasks that are mostly about just seeing things, visual tracking, localization, stuff in a benchmark like MV-Bench, the model only chooses to go into that heavy thinking mode about 25% of the time.
Right, because it doesn't need to. But then you throw something like video MMU at it,
which has complex physics, math problems.
Right, stuff from instructional videos. The think mode activation rate just jumps. It goes all the way up to 51%.
So it confirms the whole idea. Visual perception is often enough. But if that initial gut check is shaky, it calls in the heavy artillery of, language-based reasoning.
And that reasoning process can be genuinely corrective. There's this one great example in the source material with a probability problem based on something happening in a video.
And the first answer was wrong.
The first answer was likely just a low-confidence guess, but because the score was low, it kept going.
And then?
Through this really structured, step-by-step mathematical deduction, it actually revised its own answer from D to C and got it right. It forces itself to slow down and use logic.
So what does this all really mean for the field?
I mean, it means VideoAuto-R1 is getting state-of-the-art accuracy, but with this dramatic improvement in efficiency. They've kind of cracked the trade-off between being smart and being fast.
It feels like a new standard, really. Balancing performance and cost by only using that complex, expensive reasoning when it's absolutely necessary.
Exactly. When its own initial perception is telling it, I'm not so sure about this one.
So here's a final provocative thought for you to chew on. The sources mentioned that for simple visual tasks, like just finding something in a video, that whole text-based reasoning trace, it doesn't add much value.
Right. Perception is enough.
So if visual perception is often enough, maybe the next frontier isn't just about better textual reasoning. Maybe it's about finding ways for AI to do visual reasoning instantly without needing that verbose internal monologue in English. I mean, what other complex problems could be solved way faster if the AI just learned to skip talking to itself altogether?